Here's an explanation of HL. If I have two right triangles, and I know that the hypotenuse of this triangle, choose a different color. I know the hypotenuse of this triangle is equal to the hypotenuse of this triangle. And I know one of these legs is equal to one of these legs. Well, we know that we can find the missing side of a right triangle with Pythagorean theorem. So if I know these two sides, let's say that this one's 4 and this one's 5, I can find that missing side. Using Pythagorean theorem, and isn't this side going to also be the same length? So basically HL turns into SSS, but we don't say SSS because SSS works for all triangles, and this works specifically for two right triangles. So there's a quick explanation for HL. And I want to show you how to do all the questions on the first page of the study guide. So I think your first page has markings like this. So I've got a pair of sides that are congruent here, a pair of sides that are congruent here, and I've got a shared side that's congruent to itself. So then these two triangles here are going to be congruent by side, side, side. Now, some people look at this entire picture as one whole picture, but you got to remember these are two separate triangles. So if it helps, you can separate them. Not perfect, but you get the idea. This side's equal to this side. This side's equal to this side. Here's the shared side. And if it's still confusing, you can always just cover up one of the triangles and look at what you have marked. You've got 3 sides marked, so it must be side, side, side. Oh, sorry, just making sure this thing was recording. Okay, and then the second problem has markings like this. Let's see, we've got a pair of sides. We've got a pair of angles that are congruent. And then you have that shared side again. So I'm going to draw them separately to help you visualize this. Make sure this is showing up on the screen. Okay, so I've got angle, congruent to an angle. I have a side congruent to a side, and I've got a shared side. So if I cover up one of them, I've got 2 sides and an angle. So this is going to be side, angle, side. The angle is in between the 2 sides, and that's the case that does work. Okay, so this would be SAS. Next one, you've got a pair of angles. You've got another pair of angles. got the shared side. That's never going to be marked for you. So if I draw them separately, pair of angles, another pair of angles, shared side, angle, angle, side. The side is not in between the two angles, so this would be angle, angle, side. All right. We've got a pair of angles, another pair of angles, shared side. I draw them separately. Angles, another pair of angles. There's the shared side. Cover one of them up. That's two angles and a side, and the side is in between the two angles. So that's going to be angle, side, angle. Okay, next we've got a pair of sides. Another pair of sides, and then we have, what kind of angles are these? Vertical angles that are congruent. So I don't think we need to draw these separately. We can just do this. We've got two sides and an angle, and the angle's included in between the two sides. So that's side, angle, side. Okay, over here we have a side congruent to a side. Another pair of sides that are congruent. We've got the vertical angles. If I cover this up, that's two sides and an angle. But two sides and an angle doesn't guarantee that the triangles are congruent. If you don't know why, look at the video that comes before this one on triangle congruence. SSA, bad word, doesn't work. So these two triangles are not congruent. Okay. We've got a pair of right triangles. So there's a clue right there that this could be HL. Let's see what we have. We've got a pair of hypotenuses that are congruent, another pair of sides that are congruent. Well, that's the definition of HL. If you have a hypotenuse congruent to a hypotenuse, a leg congruent to leg, then you know that those two triangles are congruent. I explained that at the beginning of this video. Now, the order does matter when you write your statement. If I say triangle BAC, I have to go and match up the corresponding angles. So angle B corresponds to angle D. In other words, if I were to reflect this over a vertical line, B would map right onto D. So triangle D, and then A corresponds to F, and then C corresponds to E. So triangle DFE, reason is HL. Okay. Let's see, we've got another pair of right triangles, so maybe this is HL again. What do we have? We've got a pair of angles that are congruent. We've got the right angles that are congruent, and it looks like we have a pair of sides that are congruent. So if I cover up one of these triangles, maybe cover up the ones on the other side too, so I don't get confused. I've got two angles and a side, and that side is in between the two angles. So that's going to be angle, side, angle. So my two triangles are congruent here. If I were to name this one triangle RQS, and it doesn't matter how you name the first one. What matters is that the second one, the angles correspond. So triangle RQS, R is congruent to T, so I'm going to put T first. Q is congruent to U. Since Q is second, U goes second, and then S corresponds to V. This would be a reflection. And then the reason is angle side